Okay, looking on the board, you will see the question. The question is actually from the 2025 UTME. The question reads: Given that 356 in base x is equal to BC in base 16, find the value of x. That is what we have been given, and we are asked to look for what x is. X is the variable in that question. X is unknown, so you are asked to look for the value of x. By the time you get the value of x, then you will know exactly what base this particular number is. At the moment, we can't tell what base this number is. This is not your regular base 10 number that you would have called 356. Don't mistake this for 356. Until you solve for x and know the value of x, that is when you will know the place value of each of these digits. For now, we cannot tell what value each of these digits would until we solve for x, then we can know. Then the other one on the right hand side is in base 16. This is a hexadecimal number. Base 16 numbers are also called hexadecimal numbers. So we are going to do two things on this question for us to know the value of x. First, we need to convert from base x to base 10. Then we convert from base 16 to base 10. Then we are going to, at the end of the day, after the conversion, we are going to arrive at a quadratic equation. Then when we solve the quadratic equation, we are going to get the value of x. It is that value of x that will replace the base of 3, 5, 6 for you to be able to pronounce the value of any digit in this number. So let us solve as fast as possible so that we can meet up. We actually solved this question yesterday, but unfortunately the length was too much. Uploading it became a problem. So we are revisiting it, and as we are doing it, we are going to do it in two parts. First, we are going to solve to arrive at the quadratic equation. Then the next part of it, we solve the quadratic equation to get the value of x. So let's go. Let's bring down the equation. 3, 5, 6 in base x is equals to BC in base 16. Already I said the number on the right hand side is in base 16. When you want to expand the number that is written for you, you want to expand it, you are going to multiply each digit by the power of the base that you have been given. If you look at the number on the right hand side, 356 is in base x. X is our base. So we are going to express every digit here as a product of the power of the base. Now look at our first digit on the left hand side. Our first digit is 3. 3 will be multiplied by x, which is the base of this number here. Product means the result of multiplication. So when you multiply a digit by the base, and then you express the base in each exponent, you are finding the product of that digit and the base. So that is what the product means. So we multiply the first digit, which is 3, by x. You bring in addition here. The operation in between the digits is addition. So the second digit is 5. 5 multiplied by the base, which is x. The last digit on the left hand side is 6. You have your 6 multiplied by the base, which is x. Then you bring your equality sign here, equals to. In hexadecimal numbers, they use letters of alphabet to represent numbers. So hexadecimal numbers start from 10 to 15. You know, in number base, the highest digit in a number base is usually 1 less than the base. So if you see base 16 numbers, the highest digit is always 15. The smallest digit in hexadecimal numbers is 10, and the biggest is 16. The same thing in base 2. The smallest digit in base 2 is 0, and the highest digit in base 2 is 1. So let's go. When you see hexadecimal number, we see A represents 10, B represents 11. So we have B here. So our B is going to be 11. 11 multiplied by the base. What is our base? 16. Plus our second digit there is C. And C represents 12. 12 multiplied by the base, which is 16. Now we are going to write the base in their exponent. So we start from here. The exponent of 16, the first 16 here will be 0. The second one will be 1. You move from the right to the left, and the place value increases as you move from the right hand side to the left hand side. Now let's come to the other side. Now we are moving to the number that has x as the base. Now the first x here will have 0 as the power. The second one will be 1, and the third one will be 2. Now let us multiply the digits by the bases, by the powers of the base. Now 3 times x squared will give us 3x squared. You bring in your plus sign. 5 multiplied by x is going to be 5x. No, x raised to power 1 is x. Plus 6 here multiplied by x raised to power 0. Anything raised to power 0 is usually 1. Anything raised to power 0 apart from 0, as far as it is not 0 and you raise it to power 0, it is going to give you 1. So we are having 6 multiplied by 1 and it gives us 6. You bring in the equality sign here. 11 times 16. Now 16 raised to power 1 is 16. 11 times 16 will give us 176. You bring in your plus sign here. Now look at 16 raised to power 0, and I said any non-zero integer raised to power 0 is equal to 1. So 12 multiplied by 1 is going to give us 12. Now we are going to collect like terms. Collecting like terms means we separate our terms that are mixed up. We separate them, we arrange them. The ones that have variable will be on the same side. The ones that are not carrying variable will be on the same side. Now look at the numbers here, the terms that carry variable x. We have x squared, 3x squared, 5x are the numbers here with x. So they are going to be on the left hand side, while the constant terms, the ones without any unknown, will be on the right hand side. So we have our 3x squared plus 5x will be equal to, after the equality sign, what number comes first? 176 plus 12. Plus 12. Now you are moving 6 across the sign of equality to join the like terms of it. And whenever a positive number is crossing, it will change to minus. So you have minus 6 here. So we have 3x squared plus 5x will be equal to 176 plus 2 equals 1. Now we want to have a quadratic equation. A quadratic equation is defined by a certain features. One of the features is that the highest power of x should be 2, and the whole equation should be equal to 0. So we want to have 0 at the right hand side. So we are going to subtract 82, which is the only number at the right hand side. We're going to subtract it from both sides. So whatever I do to the right hand side must also be done to the left hand side. So we are going to subtract 182 from the left hand side and also from the right hand side for us to have a perfect quadratic equation. Let's go. 3x squared plus 5x minus, no, 182 is crossing the sign of equality, change to minus. That is why as it is crossing here, it changes to minus. Minus 182 is equals to 182 minus 182. Now we bring it down. 3x squared plus 5x minus 182 is equals to 0. Now we have successfully formed a quadratic equation from these two equations that we were given. 356 in base x equals to BC in base 16. So our next video will solve the quadratic equation using factorization method in order to get the value of x, so that we will know the base of this number that we have been given. Thank you.